Berg Knowles Theory podcast.
Hello, everyone, and welcome to the Berg Knowles Theory podcast, where we discuss AI and how you can actually use it. Our goal is to ensure that you, our listener, have the tools, knowledge, and understanding to leverage AI to simplify and automate areas of your life or business. I'm your co-host, Ian Knowles, with my buddy and co-host, Harry Berg. And on today's episode, we're going to be talking about things you've probably heard about AI, but might have questions about, which are really the three primary factions of AI, which are artificial intelligence as a whole, machine learning, and deep learning. So what are these things? What do they do? How do they apply to AI? What do they mean? And where do you use them? Those are the questions we have. Let's demystify them. So Harry, let's start on AI in general. There's a lot of words that people are saying that, constitute AI, artificial intelligence, machine learning, deep learning, language models, neural nets, all of these things. And they all kind of funnel up to this, and even robotics, right? And everyone sort of buckets everything into AI. But what is it at the end of the day? Like, what is the simplified,
Yes.
sort of distilled version of what AI is?
Yeah, this is the number one place that we absolutely need to start. What is AI? The way I like to phrase it is it's an approach to automation. And it's really as simple as that. People can give all kinds of definitions and talk about specific parts of things that AI can do, like you mentioned. Overall, AI is an approach to automation. There are many different things that we want to be able to automate rather than have to do manually. And over time, since the invention of software, we've been finding ways to have computers use that software to automate things. But there are some things which are difficult to program ourselves. They're difficult to write down the instructions for how we do things. How do you drive a car? How do you walk as a person? You might want a robot to do that. How do you write emails? How do you write all kinds of things? Those things have been very hard to automate up to this point, because up until this point, humans have had to write the step-by-step instructions for how to do these tasks, for how computers can do them. And so AI, the way I think about the most practical definition of AI is an approach to automation that lets you unlock these new kind of things, which are the things which are just difficult to describe how to do. How does AI do that? Well, AI is an approach that lets you have a computer system learn to do these things for itself, instead of having to write those explicit instructions. And there are many approaches for how to do that. And to lead on to the next pillar, which you mentioned, machine learning is one of them. So machine learning is an approach to AI.
Really quickly,
AI is an approach to automation.
Before we dive into machine learning, I want to ask a question and get your thoughts on something.
Let's go.
So AI is an approach to automation, right? And what does that mean? I think defining our terms here is important. So automation being that we can take things that we normally do ourselves manually, that might take a long time, that might pose risk, that may result in inaccurate information. But generally speaking, the thing here is that automation reduces the amount of time that we have to spend on manual tasks that otherwise would take a long time. That's the context in which we're talking about it. We're not talking about, robots that are going to go into war right now. We're talking specifically about taking tasks. We're talking about taking tasks off of our plate, letting a machine do it so that we can focus on doing things that are more important to us or more valuable to us or our businesses. So that's the core of it, right?
Absolutely. And by using software specifically is what I'm talking about. Since the invention of software, the world has been eaten up by things that software can do. So, something you might have had to do in the past is send a letter. Now you can send an email. And that's a great example of automation, where you've taken something which previously, took a lot longer, took you had to physically go and do it. Now it can be done with push of a button. And I think what we want to get to is a place where we can take every task which, is a burden to us, which is draining of our resources, and push button, get that thing done. So, email number one, like getting from point A to point B, there's a big layer of software behind Uber. Organizing files or summarizing information, writing code, all these kind of things that are tasks people do currently. And we have found in part ways to automate them. And as AI progresses in intelligence, we'll find more ways to further automate these things so that we don't have to spend the time. So that's absolutely core of the end. You're totally right. It's things which take up our time. Can we have a computer do them for us?
And to that point, I think the email reference was a really, really good one, because prior to the internet, and even leading up to, the internet era in the late 90s and early 2000s, there were a lot of skeptics, right? And they had questions about the utility of the internet. They had questions about the utility of email. They didn't think that, e-commerce or online commerce was ever going to, take hold, right? But now we're on the other side of it, where we've learned from that, incubation period of technology. Yet we're at another revolution where we've now learned those lessons. We've culturally decided, hey, we don't want to spend all of our time on computers. And now we're at this next juncture in history where, again, we've kind of learned both, in terms of business practice and what we want to be spending our time on, where efficiency can really be gained. And it meets us at a point in time where a technology has been developed, i.e. AI, to deliver on truly simplifying our day and allowing us to spend more time on, in and on things that are of higher impact or value to us. But I think that's a really, really good point. And that's why, the adoption of this technology is so critical, because those that pushed the internet away wish that they were more in tune with it at that point in time, what they could have done with it business-wise, entrepreneurially, how they could have advanced their careers, all that kind of stuff. So there's an opportunity here to dive back in at another juncture. So with AI table set.
Yes, absolutely. And our listeners are those people. We want to help everybody to be those front runners.
Absolutely. And so let's click over to, what is machine learning? What does that even mean, machine learning?
So machine learning is an approach to AI. I said that AI is an approach to automation, and machine learning is one way to achieve that. Machine learning specifically is having the computer learn from examples of data rather than by following some heuristic. So this is the kind of so machine learning is the reason why you hear about all of this, massive use of data, the need for data. Data is the new gold. And that's because to create these systems, to understand how to automate these new tasks like driving a car or writing reports, these kind of things, you need examples of data. So machine learning is the process of having a computer learn from that data. And that seems to be a very effective way to distill this intelligence, the knowledge that we want these computers to have into these machines.
Got it. So is ChatGPT a machine learning mechanism?
Yeah. So there's kind of a stack of technology which are all put together, right? You've got ChatGPT, that is an AI. The way in which it's been able to achieve that intelligence is through this process of machine learning. So that's showing the system lots of examples of data, kind of prompts and responses examples, so it can learn the pattern from those. And that same approach, the machine learning algorithm, which powers ChatGPT, is a very effective approach, which has empowered lots of other AI systems as well. So pretty much all of the state-of-the-art AI systems, whether it is Tesla's self-driving cars or whether it's Instagram's like image understanding, or whether it's your Netflix recommendation algorithm, almost all of those things are AI systems powered by machine learning. So as opposed to AI systems powered by genetic algorithms or other approaches to AI. So they've been able to do what they do because they've been trained in this machine learning approach by seeing examples of input-output data. Oh, you watch these movies? Well, which one do you want to watch next? I see all these images, and I've had labels of what are in those images. Now I can make predictions about what's in this new image.
So is an algorithm? So algorithm is built on machine learning, right? Is that fair to say?
So so an algorithm is just you can think of it like a recipe. step-by-step instructions to do something. There are, of course, very simple algorithms. There are algorithms which are easy to understand. There are algorithms which you and I use every day in our lives, like the algorithm of how to make a cup of tea. It has a series of steps. There are some which are very easy to describe, and there are others which are very difficult to describe. Some of them might be difficult but possible to describe, like how to build a car, for example. It's hard to do, but a humanly business expert can do it. And then there are other things which are kind of impossible for humans to describe, like how do we understand language, or how do we walk, that kind of thing. Or, why do we think? And so those ones where it's hard for us to even begin to explain how do I do something, how do I make a business decision, those things are the kind of things where we can't give explicit instructions. We don't know the recipe, we don't know the algorithm, we don't know how to write down those rules for how to do it. And these kind of problems are the ones where machine learning is a very effective tool, because you don't need to have the ability to write down the instructions. You can just show lots of examples of what you did in that situation or what needs to be done, and then the algorithm can be learned implicitly rather than instructed explicitly.
Right. Got it. Okay. So when I think about, algorithms and its relation to machine learning, when I go into, let's say I go into ChatGPT and I say, write me a recipe for the best blueberry muffins on the planet, I'm effectively prompting the algorithm of ChatGPT to then go and pull data sources to deliver me my request. Is that fair to say?
Yeah, that's fair to say, but I just want to distinguish, because you use a recipe in your example there. So just to avoid confusion, the algorithm I'm talking about is what happens in between you giving a prompt and receiving a response. Basically, what does ChatGPT do? What does it do step by step when that happens? That step-by-step series of actions is something that's very complicated, and it's learned from seeing lots of examples of previous text and then figuring out how to continue on from that.
Mm-hmm. So how, not to go down the rabbit hole of algorithms, but I want to further explore the relationship between algorithms and machine learning. So I'll use a relevant concept. What is actually happening when someone is scrolling Instagram and there's data being collected on how much time they're spending on certain posts, what they're liking, what they're saving, what they're sharing? All that data is being collected and it's being fed into a system that effectively says, this person tends to like these things, therefore send them more of that, right? What's actually happening between my engagement as a user and then all of what's being collected through, the machine learning mechanism to then, as I'm moving through the system, be fed certain things that are theoretically aligned with the things that I've indicated interest in?
Yeah, great question. So let's break it up a little bit and separate. I want to be clear that the AI systems that are useful, like the Instagram AI algorithm that predicts, which obviously we'll see next, they're really split into doing one of two different things. Either they are learning how to do that thing, or they are making predictions having already learned that thing. So you can think about this as the training phase and what some people might call the inference phase, where it's inferring how to predict what images or it's making predictions, right? So let's firstly separate those two things out. When you're scrolling on Instagram, at that point, the algorithm has already been trained. So at that point, it's making good suggestions. But it wasn't always that way. Initially, this algorithm was dumb. It was completely dumb. It would make random predictions before Instagram had trained it. And before any users had seen it, of course, they were doing this on their own computers, testing it before they released it onto the platform. At some point, they had this algorithm which was very, very bad at predicting images. In fact, just predict it randomly, right? So they needed to train it. And this is where data comes in. So they obviously had people using Instagram before they had AI on Instagram, and they could see which people are liking which posts. And so they had this mapping between post and whether a particular individual would like it or not. That was their data set. And that was the start of what they could use to train their prediction algorithm, their ranking algorithm, to actually be able to do the job before they put it into the product. And so the way they would do that is they would create this huge database of maybe just each row is an image, and which user liked it or something along those lines. And then they set up this algorithm, this step-by-step process where it basically said, show the image to our dumb algorithm, get a prediction, then give it feedback as to whether that prediction was correct or not. Did it suggest that did it predict that the user would like this image and they did, or did it predict that they would like it then they did? And if it was right, kind of give it a pat on the back. And if it was wrong, then push it away from making those kind of predictions. And just do that in a loop for lots and lots of examples, so that with each prediction during the training phase, the algorithm is nudged slightly more or slightly less to make that kind of prediction. So once we've done that for hundreds of millions or billions or however many examples you have, the result is that the machine learning model that's performed this algorithm of prediction feedback is able to actually capture what it means to make good predictions. And so at the end of the day, having seen all those examples, it makes the right prediction. That's the algorithm. So you've got a kind of few elements there, right? So just to recap, we've got the model is, first need to be trained in the training phase before we as engineers say, yes, it's ready to go, let's put it in the product. To do that training, you need examples of data. If you want to do machine learning, which is the approach to AI, which I mentioned, which is very effective and powers almost all of the modern AI systems that we use. And that machine learning process is something along the lines of show the machine learning model an example, make a prediction, and then give it feedback on whether that prediction was right or wrong, and tell us to do more of what it did right and less of what it did wrong. Do that and repeat for the whole data set. Maybe run through the data set dozens of times, multiple times. And at the end of the day, you have this trained algorithm, this trained machine learning model, I should say. Machine learning algorithm, machine learning model, kind of used interchangeably, but the right word to use is a model. Something that takes an input and produces an output. That is a model. It's modeling what you like by making a prediction of whether you're going to give it a like or not. At the end of the day, you've got that trained model. Now that's ready to be put into the product, to be deployed, to be making predictions in the real world. So that's the kind of full life cycle there, and getting a model from being totally random, the same way you can use it in a product. Does that make sense?
Yeah, it does. It's very complex and very complicated, but it makes sense. You can think about, think about,
absolutely. And the problem is that I've kind of, I've done this, I've explained this, hundreds of times, so it's hard for me to figure out what's not clear. So, I love getting the questions that really dive into the pieces which I'm not highlighting. So just keep it coming. Let's make it clear.
Yeah. And, we want everybody to get a cursory understanding of how this all works. You don't need to be an expert like Harry to make sense of it. And, we try to span the expert level, down to earth, so that, us plebs who aren't tech guys can understand how this whole system works. But the way that I think about it, tell me if this is right or wrong. The way that I think about it is effectively like a brain. And it's if you have a young child and, they do something wrong, you say, no, that's wrong. And then they improve a little bit and you say, yes, that's right. And over time, they learn what's right and what's wrong, and their personality and their character is ultimately shaped as a result of those experiences, right? It's the feedback loop that will bring them in one direction or the other. And, these machine learning systems and neural nets and, GPTs and language models, they operate in a similar way.
So yeah, absolutely. In a similar way is the way that humans learn, by experiencing the world, gathering feedback, and then changing behavior to do more of what we should and less of what we shouldn't. Machine learning systems, machine learning algorithms, machine learning models like GPT, they do the same thing. intuitively. I will say one big difference is that these AI models, they don't necessarily want anything or feel anything like humans do. Humans have this natural physical embodiment connection to the world where, we feel pleasure and pain through emotions and physical sensations, which these AI models don't have. So the way that we learn is based on how things make us feel, and the way that these AI systems learn is literally just an algorithm. It's a step-by-step process of if you made a prediction which would say this bad, then do the opposite of that. That's how that's a handwritten rule which humans we've been able to simplify after we can program it.
So how do you reward an AI system? How do you reward a language model so that it knows to do more of one thing and less of the other?
So it's a good question, but it's not really how things work. It's a useful intuition to have that, okay, we're gonna, quote, reward and quote, punish these AI systems, but that's not really how we train things like GPT. We can talk about reinforcement learning later, which is another approach to AI where it does have more of this explicit reward and punishment. But AI systems like GPT, they aren't strictly rewarded and punished. They are simply adjusted. So the way that they work is, back to your analogy like a brain, the brain is full of connections, and some of those connections are strong, and some of those connections are weak. And you hope that the strong connections lead you to take in all your senses and perform good actions. So the strength of those connections is what we adjust, and we do a similar thing in machine learning. So the machine learning models like GPT, various number of GPTs that you're hearing about these days, they have lots of numbers inside the computer which runs them. And those numbers each define the strength of how different parts of this neural network, which is just a machine learning model, hits an input, produces output. Those numbers determine how those input outputs are processed and how different parts of the inputs are connected to the output. So when we talk about when we talk about updating machine learning models by training them, we're talking about just changing those numbers. So it's not necessarily a reward and punishment. It's just we've given the machine learning model an input. It's predicted an output. That input might be a prompt. The output might be a prediction of the next word. And we've got a label from our data set, which word did it predict, or which word did show up in the data set. If the prediction was very far away from that, then we're going to update the parameters by a lot, because clearly current setting is not correct. Whereas if the prediction was good, we're not going to update them by very much. And so that's the kind of the algorithm which us human engineers have written into the system there. We've quite literally said, take the number which was predicted, take it away from the number which should have been predicted. That gives you the error. If the error is big, make a big adjustment to the connections of this computational brain. If not, then this part's pretty good. So leave it as it is. And then you show a different example and repeat the process again and again.
So what is deep learning? So we've covered machine learning. What's deep learning?
Yes, what is deep learning? So deep learning is the definition of deep learning is using neural networks to do machine learning. So in machine learning, you have these machine learning models. Very simply, some kind of mathematical function which takes in an input, might be words or an image or your stock price, and you want to make a prediction from those things. Might be the response that GPT gives you, it might be a classification of what's in the image, it might be what the stock price is going to be tomorrow. So machine learning models are the things which perform that mapping from those inputs to the outputs. Under the hood, that's all a mathematical function. You turn the inputs into numbers, perform some calculation, which relates to the brain analogy, with the strength of the connections being the numbers in that calculation, and eventually you make a prediction. That's the output. So machine learning model is an important concept to understand before we talk about deep learning. Because deep learning is a case where the model you're using, this mathematical function, is something called a neural network. Basically, just a very big mathematical function. It doesn't just take in the numbers and combine them once, but then it does that again and again and again and again through many layers, which is where the word deep comes from in deep learning, because the mathematical transformation which is performed on this image is, it's firstly through layer 1, then through a deeper layer, layer 2, and all the way maybe 1,000 layers deep. So you're taking your inputs, combining them, then combining those with the next layer and next layer and next layer. So it goes to this very large calculation with many layers, which is why we call it deep learning. And and it's hard to the specific structure of that mathematical function is called a neural network. It sounds complicated. It actually breaks down in some very very small, simple calculations at the end of the day, but just lots of them. So we're not just taking in our. Let's say we want to predict someone's height from their hip size and shoulder size and foot size, something like that. So we got 3 numbers. We want to eventually compute 1 number from that. Now, you might have a machine learning model, a simple machine learning model, which just takes those 3 numbers and then maybe it adds them all together and multiplies by some factor of importance. And then that's your prediction. So that would just be one transformation, right? One simple mathematical calculation. Whereas in deep learning, you would not just combine them in one way like that, but then you would take that output and combine that with some other numbers, and then again, and then again, and again, and again, through many different layers until you produce a final calculation. Something with that many layers is the neural network. And these neural networks power basically every AI system which we use today. ChatGPT is an example of a neural network. And then there's many further classifications that we can make with what type of neural network is that. It's a transformer. That's why it's GPT, generative pre-trained transformer. And there are many kind of extensions of that idea which have led to this very particular model we have today.
So to frame this, machine learning is really the process, right? Machine learning itself is really the process in which this technology effectively learns. You've got deep learning, which is taking it to the next level, right? Which is more sophisticated and complex, but deep learning is a function of machine learning. And then you've got the neural net or neural network, which is effectively what all of it sits within. So everything in those 2 buckets can be more or less categorized as a neural net. But machine learning itself isn't technically a neural net. Deep learning itself isn't technically a neural net, but it's all encapsulated in this concept of a neural net.
Yeah, I'd say that deep learning is using neural networks, though. So those things are almost synonymous, actually. If you're saying you're doing deep learning, you must be using neural networks. That is what it means. But deep learning is an approach to machine learning. Machine learning being learning to do things from examples of data. And machine learning is an approach to AI, which is how do we get computers to do things which are hard for us to write down the rules for explicitly. In other words, it's an approach to automation. So that's kind of how all of those technologies and all that jargon fits together in this one big technology stack. But at the end of the day, we're using neural networks to make predictions of things that we want to predict, whether it is the response to this prompt, the classification of this image, the acceleration of our self-driving car, or whether it's the stock price tomorrow.
Yeah, maybe better put, I see machine learning and deep learning as verbs, and I see neural networks as a noun. So you machine learn and you deep learn within the neural networks. Yeah, that simplifies it.
That's exactly right. Yeah, that's a good way to put it.
All right, wonderful. Well, that is the breakdown of AI and machine learning and machine learning and deep learning, and then a little bit of algorithms and a little bit of neural nets thrown in there as well. but that's going to wrap us up for this episode. Harry, you got anything else you want to chime in with before we wrap it up?
I would only say that this it could be very complicated stuff. So I hope that we could break it down further in whichever direction would be useful for people. But I definitely wouldn't worry and definitely wouldn't feel discouraged if any of that went over your head, because I'm one of the people who's building these things, which means I have to know about it a lot more deeply than most people need for it to be useful, and you can definitely get almost all the benefit without knowing any of that stuff that we talked about today. So I hope we can make this even more and more practical, but hopefully that was a useful foundation.
Yeah, and at the very least, it'll make you a little bit smarter. A little bit smarter. But Harry, that was fantastic.
Let's get smarter.
Well, thank you, everybody.
Yep.
Appreciate it. Have a great rest of your day. We're out.
Absolutely. See you next time.
The Berg Knowles Theory Podcast.